Hi students, in the previous class we discussed about the comparison test, 3 forms and problems on comparison test and also the problems on limit form of comparison test. To check the nature of the series, by using the limit form of comparison test, we take the help of the unknown series sigma Vn. We have to construct that series Vn in such a way that the nature of the series Vn must be known. To find out the nature of the series Vn, we use 2 tests. One is p-test, second one is geometric series, right? So that already we discussed some 8 or 9 problems on comparison test. Now we will see the next test, that is D'Alembert's ratio test. Simply we are saying that ratio test. Let sigma un be a positive series and limit n tends to infinity, un plus 1 by un is equal to L, right? Then the series summation un is convergent if L greater than, convergent if L less than 1. The series sigma un is divergent if L greater than 1. The series sigma un nature not known when L is equal to 1, that is test fails when L is equal to 1. In this case, we use another test to identify the nature. Right? Next note, if limit n tends to infinity, un plus 1 by un is equal to infinity. Here we are not saying about anything about the limit value n. That L may be infinity, otherwise plus infinity or minus infinity, or it may be 0 or it may be 1, any value. But whenever we apply the limit form of comparison test, that is limit n tends to infinity, un by vn is equal to L, there L is a non-zero finite value. It must be non-zero and finite value. In case of ratio test, limit value, it may be infinity also, right? What about infinity? This value, it is the limit value greater than 1, right? If limit value is greater than 1, the series un is divergent. Then the series sigma un is divergent, right? So this is the ratio test. Other name is D'Alembert's ratio test. So here we are using the ratio of n plus 1th term and nth term, so that we are calling it as ratio test. Generally, ratio test is applicable if we divide un plus 1 and un, sum of the terms are cancelled. In that case, we use the ratio test. What is the condition here? Un must be a positive series and limit n tends to infinity. Un plus 1 by un value is L. If limit value is less than 1, convergent, greater than 1, divergent. When L is equal to 1, test fails. Whenever L is equal to 1, that is ratio test fails. In that case, we have to go for the another suitable test, that is either the limit form of comparison test, otherwise the next test is, we call it as Rabi's test, right? Test the convergence of series sigma n equal to 1 to infinity, 1 into 3 into 5 and so on, 2n plus 1 up to this one. And denominator ends with 3n plus 2, right? What is the nth term un? Generally, nth term un is equal to the term beside this sigma. So what is this one? 1 into 3 into 5 and so on, 2n plus 1 by 2 into 5 into 8 into and so on up to 3n plus 2, right? To apply the limit form of comparison test, here it is not possible because both the numerator and denominator consisting of product of terms. If only some fixed number like 2n plus 1 by 3n plus 2 only, then we can apply the limit form of comparison test. But here we can't apply the limit form of comparison test. Like product of terms are involved in both numerator and denominator, we can apply the ratio test, right? So from this write un plus 1 value 1, 3, 5 and so on 2n plus 1. We need to write the next term also. So put n plus 1 in the place of this n plus 1 by 2 into 5 into 8 and so on 3n plus 2 into 3 into n plus 1 plus 2, right? So it becomes 1 into 3 into 5 and so on 2n plus 1 into 2n plus 3 by 2 into 5 into 8 into and so on 3n plus 2 into 3n plus 3 plus 2, 3n plus 5. Now consider limit n tends to infinity un plus 1 by un. Limit n tends to infinity. What is un plus 1? 1, 3, 5 and so on 2n plus 1 into 2n plus 3 by 3n plus 2, 2 into 5 into 8 and so on 3n plus 2 into 3n plus 5. This is the value of un plus 1. 1 by un is there. 1 by un means it becomes reverse. So it becomes into 2 into 5 into 8 and so on. It ends with 3n plus 2 by 1 into 3 into 5. It ends with 2n plus 1. Right? So up to this it cancel with the denominator term. And here also 2 into 5 into 8 up to 3n plus 2, it cancel with this term. So what are the remaining terms? Limit n tends to infinity, remaining is 2n plus 3 in the numerator. In the denominator, 3n plus 5. If you apply directly limit n tends to infinity, limit does not exist. For that purpose, we will take common n from both numerator and denominator. It becomes 2 plus 3 by n, 3 plus 5 by n, n gets cancelled. As n tends to infinity, 2 plus 0, because 1 by n tends to 0, by 3 plus 0. So what is the value? 2 by 3. This is L value. What is the 2 by 3 value? It is 0.666 like that. So which value is less than 1, right? So by ratio test, what is ratio test? Limit n tends to infinity, un plus 1 by un is equal to L, and L value is less than 1, series is convergent. Right? So because L value is less than 1, summation un is convergent. That is, given series is convergent, right? Next, see the next problem. Test for convergence of, in the previous sum, problem itself given that generalized form. Whenever sigma is given, that means it is a generalized series sigma un notation. But in this sum, just given that sum of the terms only, first of all we need to write the given in the form of sigma un, then only we can identify what is un, right? So for that purpose, just observe the given pattern and write what is the nth term. So what is the first term? First term is 2 by 1. Second term is 2 into 5 into 8 by 1 into 5 into 9. Then third term is 2, 5, 8, 11 by 1 into 5 into 1, 5, 9, 13. Right. What is the nth term? Nth term is, we have to write in a generalized form. Observe the pattern 2, 5, 8, 11, 1, 5, 9 up to 13. Right? Nth term is, if you observe the denominator, it starts with 1, 5, 9, next term is 13 and so on. The gap in between every two successive terms is 4. So, if it is third term, it is 13. If it is second term, it is 9. So, it is 4n plus 1. Put n is equal to 3. 4 3s are 12 plus 1 13. Put n is equal to 2. 4 2s are 8 plus 1 9. But just leave this first term. Right? So now coming to the numerator, it starts with 2, 5, 8, 11 and so on. The gap in between every two successive terms is 3. So we have to write in terms of 3. It is, whenever it is 2, it is 8. That means 3 into 2, 6 plus 2 is 8. 3 3s are 9 plus 2 is 11. So it is 3n plus 2. Here we are omitting the first term, otherwise leaving the first term. What is the first term? It is 2 by 1, which is a finite value 2. So the nature of the series does not alter if we add a finite number to the given series, right? So first we write the generalized form. By omitting the first term, otherwise leaving the first term, right? So given series can be written as sigma 2 into 5 into 8 into and so on 3n plus 2 by 1 into 5 into 9 and so on up to 4n plus 1, right? N starts with 2 to infinity. Just we are leaving the first term. Now what is un? Implies un is 2 into 5 into 8 into and so on up to 3n plus 2 by 1 into 5 into 9 and so on up to 4n plus 1. If you observe here, in the second term it ends with 8, in the third term one more term is added. How can we add that term? 8 plus 3, right? 11. So like that, to write un plus 1th term, put n is equal to n plus 1 here. So it becomes 2, 5, 8 and so on up to 3n plus 2. It is same. One more term here we add 3 into n plus 1 plus 2 by 1 into 5 into 9 and so on. 4n plus 1 into one more term here we need to add. To get the term, put n is equal to n plus 1, right? So it is by simplifying it, n plus 5. It also becomes 4n plus 4 plus 1, 5. Right? Now if you observe numerator last two terms difference is 3. Denominator last two terms difference is 4. So this condition is valid. 8 plus 3 is 11. 9 plus 4 is 13. Now apply the ratio test. Because in both the numerator and denominator consisting of here product of terms are there, then limit comparison test is not suitable. Apply the ratio test. Right? This is un plus 1 value. un plus 1 by un means 1 by un. 1 by un means it becomes reverse. 1 into 5 into 9, that means the denominator becomes numerator into 4n plus 1 by numerator is 2 into 5 into 8 and so on, 3n plus 2. So from 2 onwards up to 3n plus 2 it gets cancelled. In the denominator also from 1 onwards up to 4n plus 1 it gets cancelled, right? So what is remaining? Here limit is there. Remaining in the numerator is 3n plus 5. Remaining in the denominator is 4n plus 5. Directly we can't apply the limit because here suitable conversion is there, which is by taking the maximum power of n from denominator and numerator also common. So it becomes 3 plus 5 by n, 4 plus 5 by n. As n tends to infinity, 5 by n tends to 0, which is equal to 3 by 4. It is the limit value L, right? So what is 3 by 4 value? Which is 3 by 4 means what is the value? 0. Some 7 like that, right? This value is less than 1. Implies given series is sigma un is convergent by using ratio test. Sigma un is convergent by using ratio test. But we are leaving the, otherwise omitting the first term. Nature of implies given series is convergent since the nature of the series does not alter by adding finite value. By adding 2 by 1, that is 2, to that series, the nature of the series does not alter. Next sum. Test for the convergence of the series sigma 1 to infinity n square by 2 power n plus 1 by n square. Here sum of the two terms, two generalized forms are there. So for that purpose, first we see the first one nature, then we see the next one nature. If sigma un is convergent and sigma vn both are convergent, its sum is also convergent, right? Let un is equal to n square by 2 to the power n and Vn is equal to 1 by n square. So we write the given series as sum of two series. First we identify the nature of the first one. From this one, after that we will discuss the second one nature. Because it is in the form of n square by 2 power n ratio form, just we check out whether ratio test is applicable or not. What is the ratio test? For that we require un plus 1, which is n plus 1 whole square by 2 to the power n plus 1. Limit n tends to infinity, un plus 1 by un is equal to n plus 1 whole square by 2 power n plus 1 1 by un means into 2 power n by n square. So after cancelling the suitable terms, n plus 1 by n whole square, by combining these two terms into 2 power n by 2 power n into 2, and 2 power n plus 1 can be written as 2 power n into 2. These two gets cancelled. As n tends to infinity, 1 plus 1 by n whole square into 1 by 2. Now apply the limit 1 plus 0 whole square into 1 by 2. 1 by 2 is the limit value less than 1. So implies the series sigma un is convergent, right? By which test? By ratio test. Now you see the second half, which is Vn. So Vn is equal to sigma 1 by n square is convergent. What is this form? Sigma 1 by n power p is the form. Sigma 1 by n power p is there, then we use the p test, right? Is convergent for p is equal to value 2 greater than 1 by p test. By p test it is convergent. So what is the given series? Given series is sigma n equal to 1 to infinity n square by 2 power n. Same thing, by taking sigma inside, it becomes 1 by n square. It is nothing but first one is un n square by 2 power n. Second one is vn n equal to 1 to infinity. Right? First term is convergent, second term is also convergent. If both are convergent, implies given series is convergent since sum of two convergent series is convergent. Sum of two convergent series is convergent. Like that, if we have sum of two terms, otherwise three terms, we have to separate it and identify the nature of each one. Then add it one. If all are convergent, its sum is also convergent. If all are divergent, sum is also divergent. Next, test for the convergence of x to the power 2n into n by n square plus 1 whole power half. Right? If this x power 2n is not involved, then we can use directly the limit form of comparison test. But whenever x term is involved in un, right? In that case, generally we do not use limit form of comparison test. So what is un? Given that un is equal to x to the power n into take this whole power half inside, x power 2n by 2, it becomes x to the power n into n by n square plus 1 whole to the power half. Now what is un plus 1? Un plus 1 is x to the power n plus 1 into n plus 1 by n plus 1 whole square plus 1 whole to the power 1 by 2. Right? Now consider limit n tends to infinity un plus 1 by un. So limit n tends to infinity un plus 1 is x to the power n plus 1 into n plus 1 by, simplifying the denominator becomes n square plus 2n plus 2 whole to the power 1 by 2. 1 by un is n square plus 1 by n whole power half into 1 by x to the power n. Here this x to the power n cancel with this term, right? So which is limit n tends to infinity. What is remaining? N plus 1 into n square plus 1 by n square plus 2n plus 2 into n, this term whole to the power half into x is remaining because x to the power 1 is remaining. Limit n tends to infinity. Taking common maximum power of n from both numerator and from denominator. Here n square is available, here n is available. Taking common n cube from this one, it becomes n power 3 by 2 because whole power half is there. One plus 2 by n plus 2 by n square whole to the power 1 by 2. Here denominator also we are taking common n power 3 by 2 into x. These two gets cancelled. As n tends to infinity, it becomes 1 plus 0 into 1 plus 0 by 1 plus 0 plus 0 into x. So what is the limit value? X is the limit value because x is unknown, right? So case 1, when L value is less than 1, that means L is, what is L here? L is x. When x less than 1, given series is convergent. Right? Case 2, when x greater than 1, given series is divergent. What about the third case? Case 3 is when x is equal to 1, test fails. Whenever the test fails, we need to apply the limit form of comparison test. Put x is equal to 1 in un. What is un? X power n into n by n plus 1, n square plus 1 whole to the power 1 by 2 implies what about un? Un is equal to n by n square plus 1 whole to the power half, right? By substituting x is equal to 1. To apply the limit form of comparison test, we have to consider Vn. So take Vn is equal to, what is a suitable notation to take Vn? The maximum power of n involved in the numerator, which is n power half, by maximum power of n obtained in the denominator n square whole power half, which is n power half by n After cancelling it, we will get 1 by n power half. Now apply limit n tends to infinity un by bn. It is limit n tends to infinity limit n tends to infinity un by bn, which is, what is un in this case? In this case, un is n by n square plus 1 whole to the power 1 by 2. 1 by bn is 1 by n power half. 1 by bn becomes into n to the power 1 by 2. So as n tends to infinity, n power half into n power half. Taking common n square from the denominator, it becomes n. 1 plus 1 by n square whole to the power 1 by 2. This cancel with the numerator. Now apply as n tends to infinity 1 by 1 plus 0 whole to the power 1 by 2. Value is 1. Because we are applying the limit form of comparison test, here L value is not equal to 0 and it is a finite value. So what is the conclusion from this one? Implies both un and bn have the same nature. Now what is the nature of bn? Sigma Vn is equal to sigma 1 by n power half. It is in the form of sigma 1 by n power p is divergent for p is equal to half, which is less than 1, right, by p test. Implies sigma un is also divergent but this is the case when x is equal to 1. So divergent when x is equal to 1. So what is the overall conclusion? When x is equal to 1, divergent. When x greater than 1, also divergent. Less than 1, only convergent. Implies, otherwise this given series is convergent when x less than 1 and divergent when x greater than or equal to 1 by combining case 2 and case 3. Thank you.